Hey, welcome to Tricksaw. In this video, we'll be learning about partial fraction decomposition through working through a practice problem. Over here, we have the integral 3x plus 5 over x squared plus x minus 6 dx. And partial fraction decomposition is exactly what it sounds like. We want to decompose a fraction into parts. And in this case, our fraction is 3x plus 5 over x squared plus x minus 6. And our main reason for doing this so is to break down our complex fraction into smaller, simple fractions so it is easier to evaluate our indefinite integral. And the first step you always want to do when decomposing a fraction is factorizing your denominator. In this case, we get x plus 3 times x minus 2. And because we have two factors in our denominator, let's try to split this fraction into two different fractions. And we get this. Any numerator a, which is just a variable, over we can choose any one of our factors in our denominator. Let's go with x plus 3 plus any numerator b, which is a variable, over our other factor, x minus 2. And so this equation is what we're going to be working with to find out what a and b is. So what's our next step? Well, our next step is multiplying both sides of the equation by x plus 3 times x minus 2. And by doing that, we get this equation. 3x plus 5 is equal to a times x minus 2 plus b times x plus 3. And so now, to complete our partial fraction decomposition, all we need to do is solve for a and b. But how can we do so? We have two variables but only one equation. Well, the thing is, in partial fraction decomposition at this stage, you can set x to any value you want to use test cases. So what value of x can we eliminate b so we only have a? Well, if x is equal to negative 3, then we're multiplying b by 0, which eliminates it. So let's say x is equal to negative 3. So on the left side of our equation, we get negative 9 plus 5, and then equals x times negative 5 plus 0. And then from that we get negative 4 is equal to negative 5a, or a is equal to 4 over 5. Now we can do the same thing to solve for b. For what value of x can we cancel a out? And it's going to be x equals 2. So let's do the same thing. 6 plus 5 is equal to 0 plus b times 5. And so 5b is equal to 11, or b is equal to 11 over 5. So now let's go back to our step over here. And now we can plug in a and b. So in rewriting that breakdown, we'll get 4/5 over x plus 3 plus 11/5 x minus 2. So now let's look back at our original question. We can rewrite it as the integral of 4/5 over x plus 3 plus 11/5 over x minus 2 dx. And the beauty of integrals is that you can turn this into two separate integrals. The integral of 4/5 x plus 3 dx plus the integral of 11 over 5 over x minus 2. dx. And these two separate integrals are pretty simple to solve for. All you're going to get is the ln of the absolute value of x plus 3 times 4/5 plus the ln of the absolute value of x minus 2 times 11/5 plus c, which is important because this is an indefinite integral. And so that's our final answer. So that's a pretty basic overview of partial fraction decomposition. The steps you need to remember are finding the factors of your denominator and then using variables such as a and b in place of the numerators, and then just finding specific test cases in which you can try to get rid of and eliminate some of your numerators so that you can solve for the others. Thank you for watching this video. If you have any questions or any other calculus concepts you'd like me to discuss, just leave a comment down below. Thank you for watching, and I'll see you in the next video.